Welcome to my ethical hacking. This is chapter 7. In this chapter, we're focusing on buffer overflows, viruses, and worms. So the point of this chapter is to be able to explain what a buffer overflow attack is, how they work, describe some different types of buffer overflows, know how to prevent them, describe what a virus and worm are and the differences, know common virus tools, and understand how antivirus programs work. So buffer overflow. Normally this occurs when a program puts more data into a buffer than it can hold. Again, that buffer is a temporary storage area that the program uses to store data and variables. So there are a few types of attacks. We have smashing the stack, where the stack is the reserved area of memory where the program saves and returns addresses when a called instructional set is received, variable data as well, normally organized in an LILO structure. LILO is last in, last out. Essentially, the first thing's placed in the stack is the last thing to be removed. Very similar to the FIFO, first in, first out. So the attacker can place too much information on the stack or in the memory, and then the value of the return pointers could carry out the attack. So essentially, because we have that last in, last out structure, we can place code in at the very end, overflow, and then it's actually going to execute the last set of commands that were in memory, essentially. We also have an area called a heap based, and this is the memory space which is dynamically allocated for our buffers, meaning it can grow and shrink as needs change. So, common buffer overflow attacks are like a Morris worm. This uses the buffer overflow in a Uni program. Code Red uses an older version of IIS. SQL Slammer, again, earlier versions of SQL. We have a print spooler buffer overflow. That's, again, fairly old. Same thing with Apache, same thing with Outlook. The thing with buffer overflows is you want to see what's current. You can check the vulnerability websites because current vulnerabilities dealing with buffer overflow is going to be where it's at. A lot of these older ones are going to be fixed by now. So how do we prevent them? Normally we do this by auditing code, by improving compiler techniques, disabling stacks execution. You can actually implement filters for user input. You could be careful with the library files you're using, test applications and functionality, as well as validation. So if it's not a custom application, you can turn off application if it's not being used. Normally, you're going to be keeping the software you use up to date. You're going to use things like a host-based and network-based firewall. Again, test the application, verify that it is serving your needs, and it's not doing extra items. And again, principle of least privileges, you're going to pretty much give users just the right amount of privileges that they need just to do the job. All of this should help to prevent buffer overflows. Validation is always a big one, but that goes with, again, testing application and patching application to make sure it's using the current updated code. So moving on past that, we have things like viruses and worms. So what are they? Normally they're a type of malware that can cause a wide range of damage. They can do simple code tasks like eject the optical drive or keylog or do things. So viruses normally place self-replicating code in other programs. That way, as the programs get executed, the virus is spreading. Worms are viruses, very similar to viruses as well, that can spread without end-user interaction. So a virus is normally self-replicates code where a worm actually just spreads itself. Spyware is similar, but spyware is made to spy. Adware is normally used to put ads. Ransomware is to hold files ransom. Trojans are there to keep remote access. Every one of this type of malicious code does have a definition for them to function. So types of and transmission is for viruses. Normally, viruses spread through programs or human or end user spreading of those programs. We could do different types like a file infection or macro infection, some type of more polymorphic infection, maybe infect the master boot record of a hard drive. Those are all common ones. Realistically, I'm looking probably at file and macro infection because you can embed the code in a macro or in a file and spread it that way. It's again very common. We can do fast infection viruses, or we could do sparse infections. The virus types are going to change depending on what their purpose is. Like a polymorphic virus, it can change its signature as it replicates. That way it changes as it goes from one file to another or from one host to another. And that might be different from a fast infection, because a fast infection is not really worried about changing its signatures, it's more worried about spreading more quicker. So the interesting thing here is actually more about the virus payload. It's what's in it. So we could do preventers, which will paste the virus code in the beginning of the infected file. We could do appenders, which will place it at the end. We could do search routines or infection routines or payload routines. We could do different types of routines depending on what we're looking to do. And that's the thing, is our virus payload is variable depending on our needs. So let's go ahead and get into some of the history of our viruses. We are looking at some of the major viruses in the early 80s, things like the brain virus or the scores virus or the bliss virus. Late 80s, we're looking at RTM, which is one of the major worms. Early 90s, we had Norton antivirus was finally released. That was early 90s. And mid 90s, we had the first Windows 95 virus. We had Melissa. Past 2000, we have the I Love You. We have My Dorm. We have Slammer. These viruses are coming out every single day. So it's hard to classify all of them. So some of the virus tools for generating or creating your own could be the Windows Virus Creation Tool, could be the macro virus development kit, virus creation laboratories. But again, some of these are going to be harder because these are well-known tools. So signatures for these tools may be alerting by our antiviruses. So how do we prevent them? We normally prevent viruses by having antivirus. How do we prevent malware? By implementing anti-malware. How do we prevent anti-adware, or how to prevent adwares anti-adware? Essentially, we do safe browsing. We keep things updated. We be careful with what we open. We make sure all of our software is patched regularly. Maybe avoid attachments. Have backup of our critical files in our system just in case. So antiviruses, big ones that are out there like Norton and Panda and Trend Micro and AVG. Not all antiviruses are created equally. So you have to figure out, are they scanning based off of signatures, based off of heuristics, based off of integrity, or maybe by just activity blocking. If they notice certain activity, they block that way. You need to do your research on which antivirus is going to work for you, because every year antiviruses will change. So what may work one year may not work the next. Lastly, we have malware and malware analysis. So we have a very static analysis, which normally involves the decompiling or the reverse engineering of malware, versus dynamic analysis, which is more monitoring. Malware analysis is its own specialized field. So this is just, again, the very intro to this topic. And this is a nice brief overview of viruses and buffer overflows and things of that nature. Thank you.